Hello everyone, myself Soumya Vivek Kumar Trivedi, and I'm currently an undergraduate in BTech in Electrical Engineering in IIT BHU. And I'm restarting my YouTube channel again after so many years, like after 5 years of gap. Like before 5 years, I was just uploading videos on some random stuff like unboxing and some sort of thing, but I have deleted all of that videos except the one which gained a lot many views, like 12K views. So from now onwards, I will be focusing on uploading the videos purely based on mathematics, generally solving some advanced level tough problems related to JEE Advanced in mathematics, and sometimes also explaining some random or special but advanced level topic in mathematics which can be useful for many students for various competitive exams. So starting from the first video itself, I'm just uploading a question from Black Book, which is written by Vikas Gupta, and I'll be solving the question here itself. And I want you to know that after some time as well, I will be regularly uploading videos on the mathematics itself on this channel only. So if you are interested in enjoying such sort of high level problems or advanced problems in mathematics, then you may consider subscribing my channel as well. So without wasting our time now, let's just start with the today's question itself. Let's go. So okay, now let's just start from the question itself. So this question has been taken from a very famous book known as Black Book by Vikas Gupta, and it is quite relevant to the advanced sort of tough problems. And some of you might know that this problem has been occurred in JEE Advanced way before in like I guess 2019 or 2020 paper. And it's a very peculiar problem. Like if you know the formula behind the unique concept residing in it, then you will be able to solve it in minutes, not in minutes, but in seconds as well. But the thing is, my main goal here is not to make you learn the formula behind the unique concept in it, but I want you to learn that if a problem comes in the exam, which is based on some unique kind of concept that you have not been taught by any of your teachers or tutors or coachings, and you have not seen a question on that kind of topic, then how you will approach from the scratch and how you will decode it and how will you derive at the final point after just devouring whole of the unique concept, and how will you arrive to the answer under the time pressure in the exam itself. So that is the main point of my making this video here. So now without wasting more time, let's just get started with this problem. So here the integral has been given as 0 to 2 under root of 1 plus x cube plus cube root of x squared plus 2x dot dx, right? And the main point here that will lead us to answer is having a keen observation. Like here you can observe that the power of x is 3, and here the whole function is being cube rooted, which if observed carefully will lead you to think that it might be a combination of function plus inverse itself, right? And this thought is by the way good for this problem, but it won't directly lead to the main integral that we want to reach, because as you can see, the inverse of this function is not this. But we can cleanse it up by just adding and subtracting some things, and we can just arrive at the form of this equation. So let's just do that. So now I'm gonna consider a function fx is equal to under root of 1 plus x cube minus 1. And I have considered this function because I have a feeling that the inverse of this function is the second function, is really the second function, because as we might see that if we directly calculate this inverse like with the old good method, by replacing x and y at that places itself, then we will be able to see that x plus 1 whole square minus 1 whole cube rooted gives us y, which is nothing but f inverse x, which is the second function itself. So in this way, we can now simplify whole of the integral as nothing but 0 to 2 under root of 1 plus x cube minus 1 plus cube root of x squared plus 2x plus 1 for the compensation. So now the main point here is for us to know that how will we solve a problem of the form fx plus f inverse x dot dx without getting known with any formulas. So here simply we will just do a thing that will replace f inverse x as gx, and we will get an integral as a to b fx plus gx dot dx. Simple. And now we can just do some very common steps like taking out gx common, and we'll be left with fx by gx plus 1 dot dx a to b. Now the step that is residing after the step is quite very important and is quite crucial, and for most of the students who aren't able to solve this type of equations, I'll just step on that step only. So the step is that we know that gx is f inverse x, right? So we already know that f of gx is x. Now if we differentiate this equation of both sides, then we get 1 is equal to f dash of gx into g dash x. And the main point and the main trap that I was talking about is, if this is equation 1, then we need to replace this 1, okay, in this integral itself. It might look complicated at the first step, but trust me, this step will surely lead to a solution of this integral. So I'm just gonna put it here, that is fx by gx plus f dash of gx into g dash x whole of dx. Spot on. So now this will get reduced to fx dx. We will keep this separately and even focus on the second part first, that is f dash of gx g dash x dot dx, right? So it may still look complicated, but this integral is way too simple to solve, right? It's way too simple because it requires only one substitution, that is gx is, oh sorry, I just messed up here. It should be gx multiply and hold this function, okay? So now we'll just put gx as t, and if we differentiate both sides, we'll get dt is equal to g dash x dot dx. Now it is very simple to solve this integral, which will change to, since x is going from a to b, we'll replace t as ga to gb, and this will turn it as t dash f dash t dt, and plus this alone part that we were talking about, okay? Now the main thing here is that, like, if we just observe the original equation, I'm talking about the original integral, that is, what was it? It was like, let me see it. Under root 1 plus x cube minus 1 plus cube root of x squared plus 2x, right? So if this here is x and this here is f dash x, sorry, f inverse x, that is nothing but gx, then it is very clear that if you observe, if this is a and this is b, then the result that here comes out is fa is equal to fa is equal to ga is equal to a, and fb is equal to gb is equal to b. You can just simply check this by simple calculations. Like if you put 2 here, it will become 9, and square root of 9 is 3, and 3 minus 1 is 2, and this will also result in cube root of 8, that is 2. So this thing literally holds. So now using this thing, will be simplifying this integral. Here we can replace ga gb by a to b, right? Because g is a and gb is b. T f dash t dt plus a to b fx dot dx. And each and every G aspirant must know that the simplest property of definite integrals, that I can write this whole function as a to b fx plus x f dash x dot dx. Correct. So now this is literally very easy to solve. Like, you can just solve by putting x fx is equal to t, and then dt will result in fx plus x f dash x, which is the same thing here, by the way. So it will be a to afa bfb of dt itself, which will result in bfb minus afa. So I was just talking about the thing that this is the result that many of the coaching institute and many of the tutors force their students to learn and mug it up, that if a question arrives in which there is summation between the function and its function itself, then you must remember that if the limits are from a to b and the condition in the problem just here satisfies, like I have done before, fb is equal to gb is equal to b, and similar for a as well, then you need to write it down as this. But this is the wrong way to teach, because as far as I know, if another kind of unique conceptual problem arrives in the exam and you're not known about the formula, and that type of problem has not been discussed in your class, and if you have a habit of mugging the formulas up, then you won't be able to approach it in a simple way under the time pressure of the JEE Advanced exam itself. So my main goal is that every integration problem, like, and any of the problem of mathematics, you just don't need to learn the extra formulas more than the other than the fundamental formulas that are given in the textbook or are just provided like similarly by the teachers as well. So in that case, you need to develop your understanding that how can you build your mindset, build your approach for unique conceptual problem starting from scratch. Because as far as I believe, if there comes a problem, it means a totally different concept is involved, then I'm sure of it that that problem will be easily solved by the fundamental concepts and the fundamental formulas that you have already learned. And there is no prerequisite of having in mind this formula for this kind of particular problem or any such kind of particular problem. Like, you don't need to just mug it up the different situations, different scenarios and different concepts. Like, if this concept arises, then I will be using this formula and so and so. Then the main point is, if you just are aware about the fundamentals, you can say fundamentals or fundamental formulas of particular chapter, like fundamental formulas of integration involve that standard things like x squared plus a squared dx, which can easily be derived by your own self as well. But if these are fundamental things like f inverse x derivative, like we just do it as f of g of x equal to x, and then we derivate on both sides like this, and we can ultimately we can g dash x is equal to 1 upon f dash of r gx. So this type of things should be kept in mind, or you may not as well if you are just good at pictorial memory, or else there is literally no need to mug up or just learn the different scenarios according to the problems. So now we'll be just applying this concept or this derived result to our initial equation, and we'll be getting the answers right after. That is 2f2 minus 0f0 plus, don't forget the integration of 1 dot dx from 0 to 2. This will lead to 0, and f2 is nothing but 2. This will lead to 2, and the answer then comes out to be 6. So in this way, you can even check in the Blackboard itself, the answer itself is given 6 only. So that is all for today's video. And yes, I will be very active in uploading more such videos in the future regarding some conceptually tough advanced problems. This first problem was not that tough. I will rank it as like medium or easy to medium problem according to my category. So in the future, gradually, step by step, I will be increasing the level of the questions that I will be putting on this channel. So please stay tuned for that. And if you really like the video and like you understand the whole concept and my motive behind putting this question as my first question for this channel, then please like consider subscribing so as you will be able to get advantage of understanding more such difficult problems or problems way tougher than this as well in the future. So that's for all today. Thank you. Stay safe. Bye.